Alrighty, in this video we're going to be doing LeetCode problem number 1207, which is unique number of occurrences. This is an easy problem and it states given an array of integers, return true if the number of occurrences of each value in the array is unique, or false otherwise. Example 1 here has 1, 2, 2, 1, 1, 3. The answer is true because we have 3 occurrences of the number 1, 2 occurrences of the number 2, and 1 occurrence of the number 3. Example 2 is false. We have 1 occurrence of 1 and 1 occurrence of 2. And so on and so forth. So how are we going to do this? Well, we need to count each one of the numbers, the count of the numbers in the array. So the first thing we're going to do is we're going to sort the array. I hate it when it doesn't give me the IntelliSense. Alright, so we're going to sort that. It'll be a lot easier to parse through it. So we're going to store these in a list. So we'll make this a integer. Numbers are integers. And I'll call it list, and this will be a new array list. Let's define a counter and initialize it to 1. And now we just need to loop through this array. Less than array length. -1, 0-based indexing, I++. Whoops. I'm used to C#. We put the opening bracket on the next line. Alright. So what we're going to do is we're going to compare the current value with the next value. So that will just be array I plus 1. So the first time through, it will do array 0 and see if it is equal to the value in array 1. And if that is true, we're just going to increase the counter. Else, we got to do something else. Alright. So because we sorted these, once we get to a value that is not equal to the next value, we have the entire count of that current value, so we can just add that to the list. That will be the current count of the number in the array index I. And then we need to assign the counter back to 1 and start this whole process over. Alright, when we're done with that, so the last number, we need to grab that last number. Because if you look up here, array I, if it's not equal to array I plus 1, we added the count, but we still have I plus 1 hanging out there, the very last number hanging out there. So we just need to add that to the count. And that will be, yeah, it's not equal yet. Okay, so we do that, that will take care of all the numbers. So now all we need to do is define an integer. I can't spell integer set. And we're going to make that a new hash set. And we're just going to instantiate that with the list. Now this is the final piece. We need to return if the list size is equal to the set size. If these are both equal, so if those are both equal, then return true. If not, return false. So let's debug this and see what we get. So I use the first example where the array is 1, 2, 2, 1, 1, 3. So the first thing we're going to do is sort that. So now you can see the numbers are sorted. Instantiate list, define the counter, and just start looping through these. If array at position 0 is equal to array at position 1, which it is, we just increase the count. See, count is now 2. We do it again, count is 3. So we have 3 number 1s. Now we've hit the 2. So now we've got to add this count, so list will have a count of 3 for the 3 number 1s. And then we're going to increment or reset the counter to 1. And we've got 2 2s, so we're going to add that to the count. And now we've got that final 3s. So we're going to add the count of 2 and set the counter back to 1. Well, now we've hit the 3, so we're done. So we have to add that 3. So list add count. So if we look at the list now, it has a size of 3, 2, and 1. The number 1 here, the number 2, and the number 3. Now I'm going to create a new set, new hash set, and we'll return list size equals set size. So you see here 3 equals 3. So that returns true. So this int array has a unique number of numbers. So the 1 has 3, the 2 has 2, and the 3 has 1. Okay, one of the reasons I was not getting the IntelliSense was I used array instead of arrays. So I fixed that. It should be arrays.sort. Apologize for that. We'll run it. It is accepted and submit it. Alright, faster than 54. Memory usage less than 34%. Finally, we have the time complexity, which is n log of n. This is just the time complexity for a sort. So that trumps the other algorithms in this solution, and n log of n is our time complexity. Space complexity is O of 1. There's nothing inside our solution that grows the solution, so it's just O of 1. And that is it. So thank you for watching. Let me know if you have questions or comments, and we'll see you next time.